All right, guys, today we are doing another lab. Today we are going to be working on this guy right here. We are going to be finding the molar volume of a gas. We are now experts at gas laws. We took a test on it and we're ready to prove how good we are with our gas laws. So we have the molar volume of gas. What does that even mean? Well, a long time ago, a guy named Avogadro, we should recognize this little statement right here. He said that when you have 1 mole of gas at STP, it will equal 22.4 liters. We are going to see if we can confirm that in lab today. We're going to be trying to recreate this. Now, we are not going to be able to create 22.4 liters. That is much too large of a volume of gas for us to generate, so we'll need to do a little bit of adjusting. All right, so the way that we're going to do this, we have a general setup over here. Let's take a quick look. We have a graduated cylinder. In the graduated cylinder, I have some water. And our first goal is we are going to need to generate some gas. So the gas that we will be generating will be through a chemical reaction. We will be reacting magnesium with hydrochloric acid. So we're going to be using magnesium ribbon. So we've got some magnesium ribbon here. So it's a thin little piece of magnesium. We're going to want to first start by recording the quantity of magnesium that we have available to us. So let's go ahead and switch over to the scale here. So we're going to go ahead and open up, put our magnesium ribbon on the scale, and we are going to record this. 0.082. Okay, so we've got 0.082. Let's get that recorded. All right, the next thing that we want to do is we want to build a little cage for our magnesium. We want to keep our magnesium safe and secure in a cage. So I have some very thin copper wire here. Some very, very, very thin copper wire. And what I'm going to do is I'm going to take this magnesium and I'm just going to kind of ball it up. All right, so we're going to make like a little ball of magnesium here. So we see this ball of magnesium. And I'm going to start wrapping it up in this really thin copper wire. I'm going to make like a little cage out of the copper wire. So there's no science to this. We just start trying to kind of like roll it around in your fingers. And hopefully we start to get a cage that'll hold it. It's easier said than done, to be quite honest. This is, there we go, we're starting to get it. Keep going. You can see I'm starting to get a nice little cage that'll hold it here. Closer and closer we come. All right. The next thing that we need to do is react this zinc. Excuse me, I keep saying zinc, it's magnesium. We need to react this magnesium with acid. And we know that if I was to just do that in a test tube or something, there's going to be a lot of oxygen there, and that's going to contaminate the sample. And so we want to get as pure of a sample as possible. So a bunch of you in your heads right now should be screaming, bubble it through water. We need to bubble it through water. Yes, we definitely need to bubble it through water. And so the way that we're going to do this is we're going to use something called a eudiometer. So it's like a large test tube / it's almost like a burette, if you remember burettes. So we've got, if we look at this, it's got increments on it. See if I can get this to focus. There we go. So we've got increments, so it's through 100. But this end is open like a test tube. It's basically like a test tube. It's closed on this end, and we don't have a valve over here. So I'm going to fill this with water. But I need to get this to react. So what I'm going to do is I'm going to actually mix the acid in here. Now, if I was to just take it like this and fill it with acid to the top, the second that I put this inside like that, it would start reacting with the acid and it would fizz out and I would lose some of my gas. So the trick is to understand density. We know that things that are more dense will travel to the bottom. So I'm going to start with my acid, and I'm going to start with my acid at a fairly concentrated measure. So let me put some goggles on actually. The acid is 6 molar HCl. So what I'm going to do is I'm going to put the 6 molar HCl in here, and I have about 10 milliliters of it. So it's going to fill up the bottom. And then I'm going to gently fill this with water the rest way. And because the acid is more dense, it's going to stay at the bottom and the water is going to stay sitting on top. And if I don't shake it up, they actually won't mix. Then what's going to happen is I'm going to flip this over. So I'll be able to set my zinc, or I keep saying zinc, magnesium, into the tube here. And it's just going to be sitting in water and it's not going to react. But then I flip it upside down, and what's the acid going to do? The acid is going to start sinking down through the tube until it hits the magnesium, and it starts reacting. And now when it reacts, where are the bubbles going to go? Straight up. Now, in order to release the liquid, I'm going to be using a rubber stopper that's got a hole in it. Right? So we can go ahead and allow the water to escape through there, but the gas is going to remain trapped. So let's go ahead and get our acid in here. So we're going to go ahead and put the acid in first. So that's the 6 molar HCl. Like I said, that's kind of nasty stuff. You don't want to get 6 molar HCl on you. By no means do we want to get that on us. So now what I'm going to do is I'm just going to kind of gently tilt this, and I'm going to slowly add some water to it so that hopefully I don't allow it to mix too much. And I want to fill this up to the very top. Keep pouring here. So all of my acid should be at the bottom with a little bit of water up at the top. All right, so we see at this point, we're about full. I'm going to get it all the way up here. That's close enough. I'm going to go ahead and put the magnesium into the tube. And then I could go ahead and take my rubber stopper, and the rubber stopper will fit right on top. And I'm starting to get some bubbling, so I've mixed a little, so I need to flip this. So I'm going to flip it. So the bubbles start going up, and you'll notice that the water's not coming out right now because of the surface tension of water. It's able to hold it in. But if we look closely in the camera, I don't know if we can see this. Do you see the waves? Look at all these waves coming down. That's the HCl that's traveling down. And so what I'm going to do is I'm going to put it in here. Okay? And I'm going to clamp it. So I've got it in the tray here so I don't make too big of a mess. Okay, so we're starting to see it fizz a little bit more now. And what we want to do is just keep watching this thing, and we need to let this go until it's done fizzing, until it's done reacting. And so if we move this up to the top, you'll see that we're starting way up to the top. We're starting to get a little bubble that's collecting there. And we're gonna let this thing keep going for a while. We're starting to see more and more bubbles form as more and more acid reaches that magnesium sitting at the bottom. So we just got to be patient and let this thing go, let this thing react. All right, so we see that it's actually getting pretty vigorous now because most of it is coming down. We can see that as the bubble's filling up, the water is getting pushed down into the cylinder, which is causing it to kind of overflow, and that's why I have it in the tray. You can see up at the top, we're getting a pretty good layer of gas that's forming up here now. And we're gonna let this thing just keep going and going and going. So we're still going, but we've got a lot of action going here now. If we sort of zoom out a little bit, we can see we're getting a huge bubble up at the top. This thing is reacting quite nicely, but we still have plenty of metal down there at the bottom. All right, so it's looking like we're about done fizzing. So now what we need to do is kind of take a look and see where we're at with our volume here. So the volume, we can see we've got quite a bit of gas in here. We're trying to figure out, it looks like it's right about here. So we're just above there. So let's get this turned so that we can actually read the volume here. Let's loosen this. Okay, so we're getting that turned. So let's take a look at the volume. So let's zoom in on this. What do you guys have that as? Or I should probably get down to eye level. That would be better. Eye level it is. Sorry if I'm making you sick here. Okay. So let's go ahead and record that. Okay, next thing we need is temperature here. So let's go ahead, and you'll notice that across the top, so let me zoom out a little bit here, I laid a thermometer so that the idea is we need to know the temperature of that gas inside. And so the temperature of the gas inside, it's been sitting here for a few minutes. I would guess that it's just about the same temperature as the air around us. So I kind of set it out in the air like that. So we can go ahead and take a look over at what we've got. I've got a temperature and I have today's pressure reading. So we have 20.9 degrees Celsius. The pressure is 101 point. What do we got here? 0. I'm going 6.2. All right. So we've got our gas, we have our temperature, we have our pressure. I think we got it all. All right, so now the idea is we want to try and answer the questions there. And we want to basically see if this data equates to this, right? 22 liters of gas at STP equal to 1 mole. So one of the first things we need to ask ourselves is how many moles of gas did we actually produce? Okay, now, a lot of times people will kind of start jumping into Pivner for moles of gas. But look what we have here, right? We have magnesium. We know this. This mass right here was measured on an extremely expensive scale. I have more confidence in that than I do this eudiometer, right? That could maybe go to, 1 or 2 decimals. So what, maybe 2 decimals on that? So let's see. No, I guess 1 decimal for that. I'll have to look a little closer at it again. You guys measured it, you should know. But for this, what we're going to see here is, what did I put? I put 0.2, 50, 51. Yeah, I guess about 1 decimal. So we're going to go ahead and use stoichiometry, right? You can go Mg plus HCl was the reaction that we did. And from there, we know that we can have plus H2 gas. And so there's the gas that we produce. So if we know the mass of this, you should know the exact amount of H2 that we produced. So hopefully that'll help you guys out. You have a few questions there to answer. Let me know if you really get stuck on it. But you're going to be coming up with values. What are you trying to find? And you're going to need to adjust it, right? We are not at STP here. So when we start comparing things, we're not going to be at 1 mole. We're not at STP. So there's definitely has to be some adjustments made. So keep that in mind as you work.